welcome.
Welcome. We're starting a little bit later, trying to give enough time for people to have some foods since lunchtime was delayed. But we'll go ahead and get started, and people will be still coming. So today we have an industry panel, and the focus or the theme of this panel would be an optimistic future of robotics industry. And we have 4 panelists here: Nicholas Hiss from DeepMind, Rasta Drake from TRI, Yashash Naran from NVIDIA, and Suraj Nair from Physical Intelligence. And we will begin by each of the panelists giving a short 2 or so minute pitch about what's unique about their perspective, their company's perspective on the robotics industry. And we will start from Nicholas Hiss.
So, should I stand up or just...
Anything you want. Anything you want. I will play your video and you can...
stand.
Sounds good. You can be in control over here.
Does this work? Yeah, great. So, hi, I'm Nicholas. I'm a research scientist in the robotics team based in London. The goal of GDM at large is to create AI to benefit humanity, and we are taking this to the physical world. Our goal is to create embodied intelligence to help people in their daily lives. We are trying to create the intelligence for general purpose robots, as we are trying to teach them to reason and act with the same competence and generalities of human. Over the years, the team has worked on many different problems, not just robot arms, but also quadrupeds, humanoids. But these days, we're really focused on 2 problems primarily. The first one is achieving human-level dexterity, and the second one is unlocking the potential of robotic foundation models. Both problems, from our perspective, are key scientific challenges of today, and they're also high-value problems to unlock. We're looking at many different questions in this context: what data to train on, how to enable generalization, how to enable robots to learn autonomously, or how to leverage simulation. There are many reasons why it's exciting to be part of GDM robotics. The team is super interdisciplinary. It's research first. Being part of GDM, we can focus on large-scale, long-term problems. And obviously, we can leverage the top-notch infrastructure and the top talent pool of experts across many different disciplines across DeepMind. And from my personal perspective, I've been at GDM for quite some time. I have to say, it's the most exciting times for robotics yet. And not just because of all the progress that we've been making in the last couple of years, but importantly also because robotics and embodied intelligence are at last on everyone's mind, and there are many teams interested in contributing to our agenda. So overall, I have to say, it's a huge privilege to be part of a large group of highly talented and very kind people, and I'm very optimistically looking into the future of robotics at GDM and the community at large.
Great. Thank you very much. Next is Rasta Drake from TRI. I can help you with the transition. Oh, I guess you can do that already.
Very good. Hi, we said 2-minute pitch, so here we go. This is actually my second slide. Okay, so not everybody knows about TRI, the details about TRI. We started in 2016. We've had a sustained investment in robotics, machine learning, and simulation also that entire time. We've had a few flagship projects you might have seen. We loaded the dishwasher for a while. We've got robots running around grocery stores, trying to take robots to a certain level of maturity while using some of the best tools from research. Last year at RSS, we did, with great collaboration with Sharon, we did this diffusion policy thing. And for us, that was just an eye-opener and what we were capable of doing with those techniques. And I'm proud that we decided as a group to really get behind that. And actually we made a big change at TRI. The machine learning division and half of the robotics division has now joined forces to become a large behavior models division. So diffusion policy is sort of a single task imitation learning setup. Large behavior models is the foundation model, the multitask language conditioned version. And I'm proud that we made sort of a quick change to put our resources behind this. And then last month, some of you saw, we announced a new partnership with Boston Dynamics, and we're trying to to play with some of the best hardware and the best controllers in the world with our friends down the street. So a couple things that maybe are a little different about TRI. So we've had this really stable long-term investment, I think partly because we have robotics in the leadership. Our team has basically been doing the work that we wanted to do for since 2016 with very few pivots or interruptions or anything like that. And you should think about each company, like what is their reason for investing in robotics right now and machine learning right now. And for Toyota, it's actually really interesting to just think about how they think about this. They want to become more of an AI company, and they want us to lead the way. And we need to invent and improve new capabilities so that when they invest in future businesses, we're at the leading edge. But we don't have any immediate pressure right now to make a product. And that puts us in a slightly different space than other places, both good and bad, I'd say. We have really, really good people and a culture that I'm very proud of. We're very open source publications, models, very strong university program. So the researchers at TRI get to engage with professors all over the place. I think that's and we've had really good research ideas that come from those collaborations. And we have this a strength, particularly in ML, robotics, and simulation. So the mission for the Large Behavior Models project is actually to do fundamental, basic research in what I'm calling this sort of new science. Like I really feel like something big is we have to discover, or we have to understand how this thing that happened works, of learning language conditioned visual motor policies at scale. And just to end quickly, so simulation is actually pretty well represented on this panel, but maybe overrepresented relative to the community, but I believe really a lot in simulation as a way to move some of the work we're doing as a community to the next level of maturity with benchmarking, reproducibility. So we've been investing for a long time in Drake, and we have a world-class simulation team that's working on the Large Behavior Models project, and we're using this now in the loop to try to improve our policies. That's a quick sample. You've seen we have a driving team that did the drifting project you saw this week. There's a number of really, really great projects at TRI, but that's a quick view into large behavior models.
Thank you very much. And now we have Yashraj from NVIDIA.
So this video is not actually synced with what I'm saying. Please feel free to appreciate it as a highlight reel, but most of my content will be what I say right now. So NVIDIA's mission in robotics is to build an accelerated platform that enables any company to be a robotics company. So on the compute platform side, NVIDIA focuses on what it calls a three-computer problem. There's the DGX computer, which includes H100-based systems that we know and love for training large AI models. There's the OVX computer, which includes L40-based systems for rendering and simulation workloads. And there's also the AGX computer, which includes Jetson Thor-based systems for deploying AI models at the edge. So on the software platform side, NVIDIA focuses on building robotics libraries, simulators, simulation SDKs, and foundation models that can be used in part or in whole by any robotics developer. So now what's the role of research, right? So at NVIDIA Research, we focus on both fundamental and applied research in robotics. Fundamental in terms of solving open problems, applied in terms of enabling moonshots to succeed, like humanoid robotics. We're super active in the academic community, like conferences here, like conferences like CoRL. In fact, both of our moderators, Danfei and Rika, are either former or current members of NVIDIA. We're very proud of that. I think two examples of the compute, software, and research efforts all coming together are in the latest Isaac Lab effort from NVIDIA, which focuses on open source RL simulation software for robotics. It's the successor to Isaac Gym. In addition, there's the Groot project, which is focused on building a platform for humanoid robotics that includes things like demonstration collection tools, synthetic data generation tools, and foundation models that any humanoid company or humanoid researcher can use. I'd like to finish by saying that I think one of the most remarkable things about working at robotics at NVIDIA is actually that our CEO, who everybody knows by now, Jensen Huang. He's actually super passionate about robotics. He's a true believer in it. He kind of sees it as, there have been great AI revolutions recently in text, in images, in video, and the next great one is really coming in embodied AI. And so he's super plugged into our robotics efforts on a day-to-day basis, and he's kind of making it his mission and, opening all the doors for us to make it happen. Thanks.
Excellent, thank you. Okay, and now we have a presentation, a short one from Suraj from Physical Intelligence.
Cool. All right, awesome. So I'll keep this quick and to the point. We're Physical Intelligence. We're a startup whose goal is to build general purpose intelligence for robots. What does that mean? We want anybody in the world to be able to use our model and control any robot to do any task. We're fully focused on that mission. We've been at this for about 8 months, and we just had our first release, Pi 0, where we trained a vision language action model on a lot of data from a lot of different robots, and found that we were able to fine-tune it to do some pretty dexterous tasks like we see here. Overall, we're a very lean team. We're well-funded, and we're really focused on this mission of producing the best model possible. We're always looking to work with the strongest researchers in robotics and learning. So if you're motivated in this problem, please reach out and talk to us. Thanks.
Nice. Okay, now I will bring back the general slide. And we will go on with the questions. Sorry? Oh, great. Thank you for reminding. So this will be passed on to you all. Okay. First, we have a general question for you, whoever wants to start. The question is, we see large sums of money flowing into robotics now, and into robotics industry, into startups, into established companies, much more than what we have seen previously. And I'm wondering which advances that you have seen recently, either in research or in industry, give you the most optimism to think that, okay, now we're actually at the beginning of something new and large, and this money is actually going to get a return on investment. You can start if you want.
Okay. I think the usual thing I tell people is there are 4 things that make me think that it's different this time, or things have changed significantly. So firstly, I think we've found ways of creating competent movements for robots, either through simulation for humanoids, quadrupeds, and so on, or through imitation learning at the moment for manipulation. And these movements really achieve a quality that makes them useful. So two areas of innovation that have happened. Then I think we're beginning to see signs of generalization that we didn't see before on the behavior level. And lastly, we figured out how to bring in sort of world knowledge, general purpose knowledge about the world into robot models via foundation models, web scale data, and so on. And thus also to create a level of interactivity that we didn't have. And if you bring these sort of 4 areas of innovation together, I think there are obviously others that makes, from my perspective, for a powerful mix. None of these puzzle pieces is fully figured out, so there's still a lot of work to be done, but at least there's now a path how, if we put them together in the right way, improve them further, we may be able to create the robots that we only dreamt of like a few years ago.
That's a great list. I would, of course, add hardware. The low-cost hardware that's coming out is just mind-blowingly good, and at the rate at which it's coming out is incredibly good. Like a year and a half ago, you couldn't buy a mobile manipulator if you wanted to. Now you have your pick, and humanoids are walking around, falling down next to the lunch line. This is just an amazing time. Of course, GPUs are pretty good. Maybe that's your line. But yeah, I think there's, I mean, of course, language models and what happened there are the biggest thing that changed my worldview and trying to understand how that's going to impact control and dynamics and robotics. And I don't think it solves everything. I don't think everybody should work on it. But I do think we really need to just see how far it goes. And I think you don't have to get to 100% reliability to have robots be impactful in the workforce. So I'm optimistic.
So from my perspective, it's kind of hard to overstate the importance or the impact that things like LLMs, vision foundation models, and VLMs have had in the robotics field. I think we see it at all of the conferences. We see it in the sheer number of papers that are focused on those areas. People are leveraging them in all sorts of ways, as pre-trained backbones, as things that you can fine-tune, as components of larger systems. But actually the thing that, maybe just to provide another perspective, I think one of the things that I'm really super excited about is simulation, but kind of in the broader sense of simulation. So I think there's been, in sort of the classical sense, a lot of rapid improvement in better simulations that are more accurate and more efficient for rigid bodies, deformables, fluids, and so on, sometimes with differentiability. But I think there's also been tremendous progress, and we see it here at CoRL, in real-to-sim methods that can capture reality, represent them as nerves or Gaussian splats, and then infuse them with physical properties to make them simulatable. I think there's also been such progress in video generation models, which I think are really a type of simulator. If you imagine a multi-physics scenario that involves different types of materials, solids, fluids, and so on, it's quite difficult to simulate that or to bring that into simulation, but you could very well imagine a language or image-conditioned video generation model that can actually predict some pretty plausible outcomes of those systems. And I think the final piece of simulation that I'm super excited about is really the sort of latent dynamics models, especially in model-based RL frameworks. I think we've seen some really powerful results on things like TDMPC, Dreamer, and so on, and I think we should also view that as, perhaps part of the future of simulation.
Cool. Just to echo what a lot of the panelists said, I don't think it's just one advancement. I think there have been a number of things. To name a couple, we've seen that end-to-end imitation learning from pixels can enable some pretty dexterous behaviors that I think previously were not possible. We've seen that we can train models across many different robots and be able to control many different robots with different inputs and outputs. And we've also been able to see this transfer from web scale VLM knowledge into robotics. So I think if you look at these things together, it really paints an optimistic picture of what we can do and have one model control any robot, any task, and that makes me hopeful.
Awesome. So with a lot of these optimism and excitement, there's a lot of hype, a lot of hot money flowing to the to the field. So how do you think you can balance between immediate PR or fundraising kind of type of work and long-term research goal or long-term viability of this field?
Sure, happy to start on that one. I think this problem is really hard. It's not solved. I think we all know it's not solved, and there's some really difficult research problems to tackle before it is. So solving those problems requires capital, and I think that's why we want to be capital unconstrained to be able to explore all the different research directions. But this is really it's a long-term problem. I don't think we expect commercial applications of these things anytime soon.
Yeah, I think the hype is kind of difficult. What you really don't want to do is you don't want to lose trust in the public eye. You don't want people to see robotics videos and kind of feel like, I'm not sure if I really believe it. You want them to believe what they see. It's kind of difficult to know how to solve that problem. I think, of course, every company has financial incentives, and they're trying to attract, for example, investors and so on. I think that's important. I understand that context. I think in the research community, one of the things that we could try to focus on, and it isn't that straightforward to do, but we could try to focus on really creating reproducible demos. I think that's kind of the the ground truth for whether work really matters, whether you really believe it or not, is whether another group or another institution can actually reproduce what you're doing. I think to what Russ was saying earlier, I think the rise of powerful low-cost hardware is a key enabler to making that happen. And I also think that simulation can make that happen. If you have a validated simulation model of a particular system, then you can kind of democratize that process of reproducing it across institutions. So I think, my perspective is reproducible demos would be great.
No, I think this is all really good. This is near and dear to my heart. I really, really want to have a voice that is both super optimistic about, we don't know where the ceiling is on this stuff, but I think we really do as a community. It's actually really natural. I think we're going through a paradigm shift in the field, and it's sort of natural. We shouldn't feel bad that it's a little bit messy to begin with. We're just figuring out, getting our feet under ourselves. But I do think the next phase is going to be more rigorous empirical work sometimes for these really large models. I think we're going to study them more like biologists maybe than engineers. But I think we can build up a new set of tools for communicating what was the distribution of initial conditions that this worked for, or understand how to reliably and communicably present success rates or other things, right? Because even though we all know it's not solved, I think we don't really know how well, I don't really know how well Pi0 works. I don't really know how well anybody else's model works, because we haven't yet developed as a field the tools to really communicate that effectively. But we must, and then maybe in a few years later, the theory will catch up and we'll be predictive again, and we'll go in another wave, another pendulum swing, maybe if Tomas is here. So I really, really think it's important for the field to acknowledge this and lean into that.
Yeah, I'm not sure I've got much to add to what was already said. I mean, even at GDM, I think the robotics team has always been very sort of science-based, publication-driven, and so on. We feel the pressure from the outside that there are lots of exciting demos now on Twitter, on YouTube, and so on. And it's important to not sort of being drawn into this too much. And I think we have to make sure that as a community we can maintain the scientific rigor. Obviously, one interesting question, I think, is as we are able to do a lot more with our robots and to enter sort of the real generalist domain, evaluation will become a lot more challenging, right, and a lot more costly. And this is also going to be an interesting. So even we see this internally. Evaluation is very costly if you have many different tasks. So even if the entire community is willing, we also need to develop the methods to actually be able to do so.
Great. Okay. So now we'll switch gears a little bit and ask a few individual questions to each of the panelists. I'll start with you, Nicholas. You mentioned that there are a few aspects of Google DeepMind that particularly stand out, that Google DeepMind can bring to the robotics, both industry and maybe research community. Can you maybe pick one and say how it is something unique, something that other companies, even somebody who has large-scale investment in this, would not be able to provide, while the Google DeepMind is championing this?
Well, picking one is difficult. I mean,
yes.
I say the people, but maybe then going beyond the people. I think the access to large models at their root is obviously something that enables things that may be difficult elsewhere.
Right.
So we have.
So this connection with Google and what Google builds, right, and outside maybe of robotics, and really bringing it all together and making it accessible. Is that right?
Yeah, I mean, like many of the state-of-the-art foundation models are being developed at Google DeepMind, and sort of being able to interact with the teams, learn from them, work with them is obviously something that's hugely valuable, or can be hugely valuable.
Great. Okay, sounds good. My next question would be to Ross. You mentioned in passing this new collaboration that is coming up between TRI and Boston Dynamics. Maybe you can elaborate a little bit. Maybe people have seen it in the headlines, but maybe you can bring also a personal perspective on what you think will be interesting there.
Okay, so maybe the personal perspective is that we have a deep connection actually between TRI and Boston Dynamics. We have friends for a long time. We know each other very well. I implicitly trust the people there to do. Not only is it amazing what they've done, and in terms of their hardware, in terms of their software, I think they address the problem in an extremely good way. Are very honest about what works and what doesn't work. And they happen to have like the best humanoid in the world, in my opinion. So, and they're just down the street, and so it's just an obvious. We are starting to feel more constrained by our hardware because we had made choice to originally focus on task diversity and have bimanual pandas on a tabletop and bring every interesting task to the robot. And we've done a lot of interesting tasks, not everything. Nima, I'm not everything, but there you are. So going mobile is an obvious thing. We're going to do that. And then the big question is, what does the humanoid form factor open up in terms of curriculum? And does that make it different or easier to use imitation learning in all its possible forms? And what are the extreme capabilities of a superhuman capable robot when you're doing these kind of things? So the goal is to bring large behavior models and world-class humanoids together.
Great, thank you.
Awesome. All right, so I'll start with Suraj. I noticed that Pi is the only company, well, it only started a few months ago, that didn't show any simulation results. So can you talk a little bit maybe about your personal view or the company's view about using simulation data or simulation in general?
Yeah, so you're right. In our first release, everything was real world. We collected a lot of data in the real world, and we actually also did all of our evaluations in the real world. Now, as to simulation, there are definitely places where it can help a lot, and I think we should be exploring that more. So to give some context for the evaluations in the paper, probably was on the order of hundreds of hours of real-world robots running, and we still wish we could have done more. So I think this is a place where simulation can help a lot to give us quick feedback on how well our model's doing. Now for data collection, I think it's a little bit trickier because one, there's a number of tasks where it might just be very difficult to simulate. Especially some of the more dexterous tasks, like the laundry tasks we saw, I don't know that we can simulate those well today. Even for tasks where we can simulate the physics, capturing the diversity of the real world in sim is hard. I think we've seen promising approaches around procedural generation, real to sim, but I think there's also still a lot of work to be done. And there's still a lot of engineering that has to be done to build up many diverse sim environments with many tasks in them. So I think that challenge persists versus in the real world. You can go buy an object from the store and start collecting on it that day. So there are some benefits to scaling up in real.
Okay. So Yash, I know you personally work on a lot of industrial automation type of work, and also there's a lot of work in this area in general from NVIDIA. So do you think industrial automation will be the first market, or would it be home robot?
That's a difficult one. I kind of don't want to make a prediction about it. I think they're both problems that are very complex along different axes. So if we consider home robotics, for example, it's very unstructured environments. You often don't know what scenes you're operating in, what kind of tasks you want to solve, what objects you're going to interact with. You might have humans that you kind of need to understand their intents or anticipate their behavior or so on. I think that's extremely complex. A lot of really interesting perception problems, for example, planning problems and so on. The simulation challenge is also immense. On the other hand, we could think about industry. In industry, we might say, oh, that's a little bit simpler. The environments are so structured. We kind of know our scenes. We know maybe the tasks we want to solve. We maybe know more information about our objects, such as CAD models and so on. But the metrics for success are so unforgiving. Industry really cares about precision, accuracy, reliability. They care about cycle times, minimizing the amount of time it takes to perform a certain task before proceeding to the next one. They care about reducing human interventions. These are extremely difficult criteria to meet. I have a hard time saying which one is actually more complex or which one is not. But I would say that I think it's exciting that if the community really looks at both kind of in equal balance. I think that's what we try to do at NVIDIA. I think for the most part, maybe the robot learning community might be a little bit more focused on sort of, the open world problems in household environments, but there's so many interesting problems in industry. I think also, I'll just try this exercise, like show of hands, how many people have been to a robotics trade show before? So things like Automate, ProMat, and so on. Okay, so it's a pretty small percentage as I'm seeing it from here. If you haven't been to one, I'd highly encourage you to do so, because you will see demos that will absolutely blow your mind. In some sense, you'll be seeing things that appear very, very futuristic, solving extremely difficult problems like micrometer level insertion problems or manipulating very large, heavy objects. But you'll also be seeing them solve those problems with things that you might consider to be, technologies you might consider to be decades old. And this is a real head scratcher. So I would encourage everybody to go there and think about how can we actually fuse these two perspectives. How can, for example, we start solving industry problems, but endow it with a greater sense of robustness to noise, to error, and also a greater sense of adaptivity to parts and poses and so on.
Okay. So I'd like to actually open up this question to the entire panel, industrial automation versus home robot, but I want to make it more specific. If you want to talk about industrial automation, which vertical do you think will be the first that will see this kind of learning approaches being most successful? And if it's for home robot, what would you think it would be the biggest hurdle? Like personalization, robustness, trust, safety, or cost? So take your pick.
Okay, I guess I got the hot potato. Okay, so I think there's many different verticals. All of them have their own advantages or disadvantages. I think the sort of factory automation, of course, going to more flexible logistics, moving boxes, unloading trucks. This is, I think, can benefit from learning basically straight away and have instant returns on investment. So that is like incredibly good for the field, that we can make relatively small changes. It could start with the perception system. It can get back down to learning to move more quickly or something like this. This is already almost a safe bet, I guess. The question is whether the diversity of experiences that those robots are going to have are diverse enough to sort of feed our robot curriculum that we want. So I think we also need to explore point of service food preparation or agriculture or all these other sort of potential verticals. And I think when we think about the large behavior models, the Pi Zero models, the RT style models, then I think we need to rethink some of our business models around cases, and people have done this already in the past, but we need to rethink some of our business models where it's okay for a robot to be 80, 90, maybe 95% successful, and that's okay. People ask me a lot, like, when are you going to get to 99.9%, and then I can make a product? I don't think that's the right way to do it with these. I think we need to find ways to put these robots out, start the data flywheel, and I think they can be useful immediately. Just like GPT, right? The first time you ask questions for GPT, you think, oh, it told me the wrong answer once out of 10 times, so it's not a product. But then people found all kinds of ways to build engineers around GPT in order to make money, right? And you just have to change the questions, change the way you interface. And I will go through the same thing with robotics.
Yeah, I completely agree. I think for the types of models that we're building at Pi, in some way, starting to think too much now about a particular application, whether that be home or an industrial application, actually kind of takes away from the long-term vision. I think specializing towards a particular task can actually detract from building the most general purpose model, right? So as far as like what tasks do we want to collect data on, it's not really motivated by any industry application, but rather what's going to give us the best, most general purpose model. And I think once we actually accomplish that goal, there's going to be a number of applitions, both in industry and homes.
Companion space, like a robot that doesn't do very much, but sort of lives more through its interactivity. That could be like an area that will be unlocked early. You don't have to worry so much about how good it is at something, right? It maybe mostly leverages something that LLMs are already pretty good at. Maybe like one major concern that this may raise is not safety, but privacy actually, when you embed a robot that interacts in people's homes. But this is just a guess, right? And maybe this is not necessarily the type of robot that I'm personally most excited working on, right? Otherwise, I agree with what was said. I think from a research perspective, I don't think we want to narrow it down too much too early. And I think maybe one thing to think about would be which areas actual deployment of robotic system may aid the research. Right? I guess we've seen this with self-driving cars in a way where the perfectly teleoperatable robot, I think, from what I've seen so far in many industrial domains, we wouldn't have quite the same scenario that the robot deployed early already generates value and can be seamlessly embedded into an existing process. But if there are such areas, maybe that could then really accelerate research if we can identify those.
All right. Well, now we will consider one recent example, which some might think of as a success story, which is autonomous driving, that has already been deployed. Some of the companies have deployed cars that general public can already call up and take a ride. So I'm going to ask you to reflect on the following. Do you think this is an example of success, meaning that this is deployed, some companies are starting to make profit? Or do you think actually it's an example of something that's taken longer than maybe originally anticipated? So this is one, like reflect on whether whether we can call this success story. And if we can call this a success story, and if we were to learn from it, then what kind of lessons do you think we can learn from it? Do you think we can understand kind of what hurdles this subfield had to overcome and sort of learn from that? Or do you think there are some other maybe aspects that we can take away as the lesson? Anybody who wants to take on this?
Sure. Yeah, so I think there's a lot of aspects of the problem that are similar, but some important aspects in which it's very different. I think for self-driving, it's sort of been that the average case has actually works really well and has worked pretty well for quite some time. But it's really those rare events that have devastating consequences that have been a limiting factor. And I don't know that for general purpose robots that's necessarily the same, right? You can imagine a robot that can do 1,000 tasks, of which each task has different requirements for reliability and safety. So there it actually feels quite different to me. But on the technical side, there are a lot of similar challenges. How do you collect a lot of high quality data in the real world? How do you train models on those high dimensional inputs and then do large scale evaluation in the real world? Those are all problems that I think the folks in self-driving have seen and we can learn a lot from. And actually, at Pi, we've been really lucky to have a ton of great folks from AV, and we're constantly learning so much from them.
Cool.
So I think, the first part of your question was success or not success. My personal experience is that, I've tried out the Waymo car in San Francisco. I've tried out, Tesla FSD, and my mind has been blown. I think we should view it as a technological success for sure, right? Whether it's a commercial success, I think, still remains to be seen. It probably will be. When that actually happens, it may take some time. Now, in terms of lessons that we can learn, I think there are so many. I think AV is very much a core, autonomous vehicles is very much a core part of robotics. I think we can learn a lot of lessons on the data side. So as Suraj said, data collection, but also things like data curation, data processing, automatic labeling and annotation, and so on. I think these are things that they've had to deal with for a long time. If we just do kind of an order of magnitude comparison, I think the OXE data set is something around 10 terabytes of data. But I would imagine that a typical self-driving car company could accumulate, let's say, 100 terabytes to a single petabyte of data, maybe even tens of petabytes of data per day, right? That's orders of magnitude different in a very, very short time span. And I think they've developed a lot of really sophisticated infrastructure for handling this data and then being able to build large models from the data. In previous panels, there was also this discussion of end-to-end approaches versus modularity. And I think, autonomous vehicles, the industry has been debating the same thing for a long time, and people have taken very different approaches. Some very much focused on end-to-end, and others really taking a more modular approach, where they might be building things like high-definition maps or doing explicit path planning, or you name it. I think you can actually see kind of how both perspectives have played out in that industry. And I think that's something we can extract knowledge from. I guess I'll also say one last thing, kind of a side comment. I think I'm very, I think we're all in let's say in manipulation, at least very jealous of autonomous vehicles, because cars are useful to begin with. If cars don't have any intelligence, we'd still be driving them. We have been driving them for a long time. And so you can really bootstrap your data collection process that way. Robots, I don't think we can come up with too many examples of robots that have had a major consumer impact that we can already use as data collection systems. I think that's something that is kind of this really difficult chicken and egg problem that we need to solve.
Cool. I actually worked a little bit on driving when TRI was founded, and I spent some time thinking about the rare events kind of aspects of it, and I think Serge said it really well. I think that is a big difference. Is it a success? I think it's undeniably a success. It will continue to be more of a success. There's one way that it failed for me personally, and this is really on me, which is around 2015 or so, I told my daughter, I was kind of teasing her. I said, you might never need your driver's license. You're not going to get to drive. So she's 18 now, and I have egg on my face. But apart from that, I think the field has done it very well. So here's the interesting question for me. I think in autonomous driving, and I know enough, have done enough to know how hard it is and how diverse it is. I don't mean to say in any way that the driving is easy, but it's a little bit more like the single task. It's harder to think about multitask in driving. Of course, there are different modes of driving in some sense, but if I were to take a single skill in our manipulation pipeline and just ask people to demonstrate more and more and more and more demonstrations on that single skill, then I think our success rate, kind of plateaus. It'll take a really, really long time to go up to 100%. And I think a fundamental question that the field should answer is, if I instead change the curriculum to be this much more multitask and embrace the diversity of motions that a manipulator can go through, then does that change the curriculum enough that you get to the corner cases by handling the mean on enough different tasks, that it brings you like a rich enough set of motions that you always have something in your toolkit available? And I think that's the way it's different and potentially an unlock, but we'll see.
I don't know too much about self-driving. I'm still waiting to do my first properly autonomous drive in London. It seems to be less popular there than it is perhaps in parts of the US. My hunch is that actually with robotics, in a way, we've got a lot more choice, and from a commercialization perspective, for instance, where we engage, right? Sort of there's a broad range of tasks. Some can be made very safe because a human will get anywhere close to the robot. Others obviously have a lot of the same safety concerns. They can be a lot more narrow or a lot more diverse. I think the long tail is probably quite different. We can potentially control this a lot more. So I sort of, depending on which part of robotic we are looking at, I feel there are obviously a lot of similarities on the technical side, data processing and so on, modular versus non-modular models. But maybe in terms of thinking of it from a business perspective, my hunch is that it might actually be quite different.
Okay. In the interest of time, I'm going to conclude the panel with this one last simple question. I promise it's simple. So you're a roboticist, and regardless of your role, company or elsewhere, are you personally optimistic about the future of robotics?
Pretty much so. Sorry, actually, could you repeat the question?
So are you personally optimistic about the future of robotics?
I think so. I think probably my biggest concern is that the hype kills the real progress. And that we put ourselves, and that this leads to a backlash. Otherwise, yes.
I'm super optimistic. I'm having the time of my life. I feel you all should appreciate. I'm a bit older than most of you. It's not always this fun. It's always fun, but we're in a time where it is changing at such an incredible rate, and it is absolute. It's like drinking from the fire hose, of course, but it's so good. to be a part of this right now as this kind of new set of tools is taking off. So is it going to mean robots in the home in 5 years? I'm not saying that, but that's not my immediate goal. In terms of like learning, understanding control in a different way, seeing robots do things they never did before, like I'm having the time of my life, yeah.
Yeah, I'd have to agree. I guess the title of this panel is An Optimistic Future of Robotics Industry, so it would be strange if I disagreed, but...
No, it's your opinion. Maybe you have skepticism, but...
No, I'm very optimistic. Like, I wouldn't want to, again, I don't want to, make predictions, especially when it comes to when will this, a particular breakthrough happen, or when will, robotics in this particular subfield be a commercial success. But I'm very optimistic that embodied AI is kind of an inevitability, and that we are all kind of working towards that direction. It will happen at some point, and that with exploration of a diversity of perspectives and approaches, we will eventually get there. I think I'm super optimistic about that. And even if you're pessimistic about the future of robotics, and you might say, this thing could take 15 to 20 years, shouldn't we even be optimistic about that? Like, that means that we all still have jobs. Nice. We can continue to do research, and to Russ's point, this is really fun. How lucky are we that we can, I know academic life can be stressful at times, but how lucky are we that we can wake up every day and work on robots? That's science fiction, but we get to do it as part of our job.
Sure.
Yeah, absolutely. I'm incredibly optimistic. I think there's just so many really interesting research problems to tackle, and there could be some really amazing things on the other side, or maybe not, and we're going to learn a lot along the way. And so I think no matter what, it's an incredible time to be in robotics.
Okay, thank you very much. Thank you for being here, and hopefully you can, if you meet our panelists somewhere roaming around the corridors, then you can challenge them a bit more about their opinions and everything. But I hope you've enjoyed this discussion.
Let's give a round of applause.